welcome.
Yeah, thank you.
I know your biggest project of 2020 was the publishing of your book about the Google Cloud Run.
Yeah, that was arguably my biggest thing in 2020. Because I wrote most of it during a global pandemic with my kids running around because of the school closures, and writing that book has been a great experience so far. Yeah.
So that brings us to the question: what will be your challenge for this year?
My challenge. Obviously publishing a book with O'Reilly leads to all kinds of new opportunities. And I will tell you about some in the talk. So I don't want to steal my own thunder.
Okay. Well, I have one more question. And when I look at your Twitter timeline, I saw also a lot of Japanese in the drawings. What is that all about?
Yeah, so apparently Cloud Run is really popular in the Japanese community. So in the startup community in Tokyo. So I made a few friends there, and we're now working on a Japanese translation of one of my blog posts. And that involves trying to translate my diagrams as well, and that has been a challenge because in Japanese you don't have word boundaries like we have in English. So there's no spaces between words, so I will get this translation of a label on the diagram, and then I will need to figure out where to break the word if I want to put it on multiple lines. Yeah, so a really nice experience to figure that out.
Okay, well, let's go to your talk now.
Yeah, sure. Yeah, so before I head full into the talk, I want to explain Google Cloud Run in one diagram and tell you why I, as a software engineer, am so excited about it. And that's because the developer workflow is this straightforward three-step process. So first, you write your application using your favorite programming language. And the only requirement there is that your application should start an HTTP server. And then second, you build and package your application into a container image. And finally, you deploy the container image to Cloud Run. And then once you've deployed your container image, you'll get a unique HTTPS endpoint back. So that means you don't have to manage HTTPS yourself. Cloud Run then starts your container on demand to handle incoming requests and ensures that all incoming requests are handled by dynamically adding and removing containers. As a software engineer, it's hard not to get excited about this, right? Because this is a process that lets you focus on writing your code, making a great application, and not the infrastructure that runs underneath. It will be like, here's my code, and then go ahead and deploy, run, and scale that for me, because I don't want to know how many servers you use. Just make sure that it runs right, and that it handles all the traffic that I can throw on it. Yeah, but before I tell you more about Cloud Run, I want to also tell you a little bit about me. So my name is Wietse Venema, and for international listeners, my name is pronounced like we, like in the English we. We go to the park, we. Wietse. So with that out of the way, I'm a software engineer by trade, and I'm also a trainer at Bings.io, and we are a cloud native IT services company in the Netherlands, and we are strong in engineering, training, and digital transformation. And we work with all public clouds, Google Cloud, Amazon, Azure, and Alibaba. So I like to draw diagrams to explain things, and I'm sharing those on my LinkedIn and Twitter, as Natalie showed. So I will be sharing them in the feed, the links. So feel free to connect with me or follow me. Yeah, and I'm from the Netherlands, as you might have guessed from my accent, which means you can ask me everything about Cloud Run and about bicycles. I counted this morning, and as a family of 4, we own 10 of them. I have a lot of bicycle jokes. I won't do them all for you. So one more thing, super important, and people confuse this a lot. I am not the famous Wietse Venema. That's the guy who created Postfix and now works for Google. So that's super confusing if you're also contracting for Google Cloud. People pull him into your Google Docs all the time because he is Wietse at google.com. Well, That's not me. I'm this one, the non-famous, but well, the renowned author one. Yeah, so about that book. This is my main professional accomplishment in 2020. I wrote the O'Reilly book about Cloud Run. And well, when I said in the introduction that I wrote it in the middle of a pandemic with my 2-year-old and 4-year-old running around, the last part was a lie because I wrote most of it after 10 p.m. when everybody was sleeping. I'm a first-time author, and this has been an epic learning journey for me. And the best thing is that people really like my book. And to be honest, that's quite a relief if you've just spent 2 solid years creating something. And here's Kelsey Hightower. He's a well-known person in our community, and he wrote the foreword to my book. And this is his leadership has been an inspiration to me and to many others in the tech community. And this is what he wrote. This is in the book. I've onboarded thousands of customers, and I wrote a framework to help Go developers build Cloud Run applications faster. And even I learned a thing or two from this book. What took me 3 years to learn, Wietse delivers in less than a dozen chapters. And as you can imagine, I'm super, super proud of this achievement. But like, what makes me even more happy is that people are actually buying my book now and using my book to do their jobs. And Simon here is looking forward to using it in his upcoming products. And Silvio wrote me to tell that my book has a real impact on his day-to-day projects. And there's another thing that that resulted from writing this book, because I'm now also working with Google Cloud to build the new application development with Google Cloud Run course. And in a way, the very session you're in now is a sneak preview of one of the modules in the training course, as the content is inspired by my work on the course. So about this session, coming out of this session, you will understand how Cloud Run compares to other compute platforms on Google Cloud. It will help you understand what workloads might be a good fit and the ones that aren't. And assuming that I don't run out of time, there's a demo at the end and time for questions. About questions, if you have questions, this has been mentioned before, but please pop them in the comment box. I will monitor it during my presentation and answer them on the spot if it fits the story. But I guarantee you, I will come back to them at the end. Yeah, about that comment box, it's up to there. Open it and tell me something about you. Let me know where you're from and well, your country, your city, and your role, please. One question already. While you were typing, I will answer Sietz's question, because he asks me, do you get to pick your own animal? The answer is no, I didn't get to pick my own animal. So they pick it for me. And the rumor goes that if you start like asking for them to that you can, as an author, can pick the animal, then you will get a very ugly fat fish or something else. And this is just a rumor, I can't confirm it. But there's always a story behind the animal, right? So my book has a bird. So yeah, well, that makes sense because it's in the cloud. The Dutch name is lepelaar, and that's a bird that you will see a lot in the Netherlands and not really somewhere else. So that's the second thing. And then there must be a third reason, but I didn't uncover it yet. So if you figure it out, let me know. I will be very happy, because that's also something that you don't tell. They don't tell you. So I'm waiting for those locations in the comment box. Please share it with me. Hello from Amersfoort. Hey, that's where I live. Utrecht, Den Haag. Wow. Do we have any international visitors? I had people from Brazil and Vietnam. I mean, the whole COVID thing made, I don't know, people are much more used to visiting online events, it seems. Belgium. I think it's a bit too late for India. It's a lot of visitors from the Netherlands. But anyways, if you're looking at the recording, that this won't make sense, so I will keep it short. But hey, good to know. Yeah, so let's head into the talk. Oh, more Sweden. Yes, we have an international visitor. Israel. Oh boy, I love this. I had a guy from Vietnam last time, and one from Ivory Coast. I'm actually, I had French in high school, and they convinced me to do this talk in French. So I'm practicing my pronunciation now. And there's a lot of firewalls in France, and then they connect the words when you connect them. That's une liaison. Anyway, I won't keep you any longer. Let's start by introducing you to, or refreshing your knowledge of, containers. Well, let's first start with the structure of a container image. A container image is a package with your application in it, along with everything that it needs to run. For example, in a container image for a Java application, your application is packaged together with the appropriate Java virtual machine. Okay, that might still sound a bit abstract, so let's zoom in a bit further. This is a good way to think about the container image. It's an archive with files, and those files include system libraries, executable programs, data files, such as for any web application, HTML files, images, binary blobs. And if you use an interpreted language such as JavaScript or Python, your application source files might even be in there because, well, that's what your application needs to run, right? All right, so in the rest of this session, I'm talking about container images and containers. And both are different concepts, so it makes sense to define them. If you run a container image, that's a container. Running a container image means that you're executing one of the programs that are stored inside the container image. In case of that Java application, the program you execute is the Java virtual machine. And a container represents the running processes of your application. It only exists at runtime. If there are no running processes, there is no container. And then there are two other important characteristics. Well, there are more, but these two are really important to remember. So first, the files from the container image are used to create a private file system for the container. These are all the files that the processes of your application will see. And then second, your application has access to a virtual private network interface with a local IP. And this means that you can always open a port and listen for incoming connections. So, and this is exactly what Cloud Run expects your web application to do. It wants you to listen on port number 8080 to handle HTTP requests. And in case you're wondering, that's including HTTP2 and gRPC bidirectional streaming that just launched in preview this week. But it has to be HTTP. You can't, for instance, start an SMTP server and expect that to work. It has to be HTTP. And also that port number 8080, it's a configurable default. So if port 8080 is like hard to listen to because I don't know you run Ruby or some arcane stack that doesn't let you change the port number, you can change it. And also, you might listen to this and you might think HTTP, that sounds a bit insecure. Don't we want to use like something more like HTTPS, for instance? You don't need to provide that because Google's infrastructure handles that for you. And your traffic is always encrypted when it goes over Google's internal network. So besides the requirement for your binary thing, your application, to start an HTTP server that listens on the correct port, there's no restriction. You can use any programming language, using any dependency, using binary dependencies. I mean, you can even compile COBOL code and run that on Cloud Run. If you get it to run in a container, it runs on Cloud Run. And that's super powerful because containers can run anywhere. Right? So once you have your web application packaged in a container image, you can run it on Google Cloud, for instance. You can run containers on Compute Engine in a virtual machine, or on a Kubernetes cluster, or on a Cloud Run, which this talk is about. And on your local machine, you can use Docker or Podman, and both are container runtimes. So before we move on, here are the 4 key things you need to remember from this short review of container technology. A container image is an archive with files. It includes executables, system libraries, data files, and more. A container is a running container image. It represents the running processes of your app. And then a container image packages everything your application needs to run. If your application is a Node.js application, for instance, your source files are in the image next to the Node.js runtime. Cloud Run expects your application to start an HTTP server, but your traffic is always encrypted on the Google network. And the public endpoint, you will get that from Cloud Run, is HTTPS. So you don't have to manage SSL or TLS termination yourself. Now, after this short introduction, let's explore how to get your application to Cloud Run. When you deploy a container image for the first time, Cloud Run creates a service. And service is a very broad and non-specific word, but it means something very specific in Cloud Run. And the specifics will become clear during this session. But the first thing to know is that a service has only one active container image. And the second thing to know is that every service has that public unique HTTPS endpoint, which is managed by Cloud Run. And Cloud Run receives incoming requests to that public HTTPS endpoint. And to handle the requests, Cloud Run starts your container image on demand. And then it also makes sure to handle all incoming requests by starting more than one container if that's necessary. That's a feature called auto-scaling, and I will come back to that later in this session. So now, in case you're already familiar with Google Cloud, you're probably wondering right now if you can also route incoming requests from the global load balancer to a Cloud Run service. The answer to that question is yes. And in that course that I mentioned, I will come back to that in more detail in one of the modules. So I want to pause again here and direct your attention to the word service, because this is a key concept in Cloud Run. So you create a service to deploy a container image, and each and every service has a unique name and associated HTTPS endpoint. Like it will have a URL like the one I show in the slide, HTTPS hello, that's the name of the service. Then a unique hash that's unique to your Google project, and then the Cloud Run domain. You can use custom domains if you want. And then as a developer, you'll interact primarily with a service resource to perform your tasks, such as deploying a new image, rolling back to a previously deployed version, and changing configuration settings like environment variables, scaling boundaries, very important with serverless, because, well, maybe you've read the blog post of the guy that like called his Cloud Run service from his Cloud Run service, and then that scaled up. Well, you don't want to know what happened next. Let's take a step back and look at how your container image gets to Cloud Run, because you're not sending it directly to Cloud Run, but you use Artifact Registry as an intermediary storage for it. And that's because Cloud Run can only pull container images from Artifact Registry. If you're used to hosting your container images somewhere else, like on Docker Hub or on a registry you host yourself, keep in mind that with Cloud Run, you'll need to push them to Artifact Registry first. What is Artifact Registry? That one's quick. Artifact Registry is a fully managed service in Google Cloud, and you might know this as Google Container Registry. And Artifact Registry is a universal package manager. You can also use it to host Java packages, Node.js packages, and containers, right? Then it's a Docker repository. And then Cloud Run can pull those from those. So let's take a look at how that works. As soon as you're ready to deploy your container image to Cloud Run, you begin by pushing, that's uploading in the container language, the image to the Docker repository on Artifact Registry. Your container image will have a unique name, a unique image URL in that repository, which you then can use when you deploy to Cloud Run. This means you hand the, like I show in the slide, the command line command you use. So you say Cloud Run deploy image and then the image URL. And this means you hand the container reference over to Cloud Run, which then pulls the image from Artifact Registry. You can also do this, like I showed the command line example, but you can also use this, do this through the web console. And then finally, Cloud Run pulls the container image from the Docker repository. And to ensure that containers on Cloud Run start reliably and fast, Cloud Run will copy and store the image, the container image locally. And this internal container storage is fast, right? So this ensures that your image size is not a bottleneck for container startup time, because large images like your, I don't know, your 4 GB Python with a lot of libraries, that loads as quickly as one small, fast, statically compiled Go application of 9 megs, right? So, and because Cloud Run copies the image, you won't get into trouble if you accidentally delete a deployed container image from artifact registry, or change the tag, I don't know, override latest, and then suddenly a different version is running. That won't happen, right? Because it makes the copy when you say deploy. So I've just explained, short intervention. I've just explained to you how to get your container image to Cloud Run through artifact registry, but I didn't even talk about how to turn your source code into a container image in the first place. And that's because that's another talk, right? And because you will do that with Docker, and some people really like it. And that's okay. I mean, for some use cases, using a container-based workflow is great because it gives you a great amount of transparency and flexibility. If you build the container image, you have the power to decide exactly what file ends up in your container image and how it gets there. However, in some cases, that power is just too much to handle. Sometimes you're just looking for a way to turn source code into an HTTPS endpoint, right? Here's my code. Go ahead and deploy it and run it for me. I don't want to write a Docker file. So you will want your vendor to make sure that your container image is secure, well configured, built in a consistent way. With Cloud Run, and this is good, with Cloud Run you can do both. You can use a container-based workflow as well as a source-based workflow. And at the very end of the demo, I'll show you how to do a source-based deploy. Now let's talk about autoscaling and on-demand containers. What does that mean? Cloud Run starts your container to handle incoming requests. And multiple requests can be handled by a container at the same time, concurrently. And as long as a container is handling requests, Cloud Run will not shut it down, and unless something bad happens, like your application crashes. And I emphasize concurrency because, like, if you use a function as a service platform, it's one HTTP request per container exclusively. But on Cloud Run, it's just like a regular app. And then Cloud Run automatically increases capacity when necessary to make sure it handles all incoming requests. And this is a feature that's known as autoscaling. And this is how that works, right? I show it on the screen. Every service has an internal HTTP load balancer. And this load balancer distributes requests over a group of available containers. And if all containers are busy, and Cloud Run looks at the CPU usage, for instance, if all containers are busy, it starts adding additional containers to the service. And as soon as demand decreases again, Cloud Run stops sending traffic to some containers and shuts them down. The number of container instances in a Cloud Run service is limited to 1,000 instances by default. Like if you need more, you can submit a request for a quota increase, and it will happily add more capacity to the Google data center, and you can scale out. However, over 1,000 containers can unleash a lot of load on downstream systems. And APIs such as your relational database, they might not be able to handle that, right? So you'll find yourself lowering that limit more often than increasing it to safeguard the stability of your system. Now, and this is good. When no requests come to the service for a while, Cloud Run shuts down all containers. It scales to 0, right? And a fresh container will start on demand as soon as a new request comes in. You might have heard of this. This is scale to 0, right? Cloud Functions do that. Cloud Run does that. And this process is attractive for economic reasons, as this means you're not paying for idling containers, which you are if you would have used virtual machines. But that's not the whole story, because the pricing model on Cloud Run is unique. You only pay for the system resources you use while a container is handling a request, with a granularity of 100 milliseconds. So most of the other compute products, such as for a compute engine or a Kubernetes engine, they charge for servers as long as they're running, even if you're not using them. And that means you're often paying for idle server capacity. I mean, you've seen this on a product, right? We need to over-provision a bit because, big demand might come this weekend, and let's add a few more servers. And then suddenly you're only utilizing 30% of your cluster. That happens. more often than you think. I want to emphasize that you're charged for container time and not request time, right? So if your container can handle 50 requests at the same time, you're not paying 50x, 50 times for the same request, but one time for the container time. And then the price of the container time increases with CPU and memory. It can go up to 8 gigabytes or as low as 128 megs. And you can go up till 4 virtual CPUs. But then a container with more resources is more expensive. So now that you know, So now that you know how the pricing model of Cloud Run works, it won't be a surprise that the lifetime of a container on Cloud Run is only guaranteed while the container is handling requests. So if a container is not handling any requests, Cloud Run can shut it down. I have a question about the cold starts. I'm going to come back to that after the demo, in the demo. So if a container is not handling requests, Cloud Run can shut it down. That doesn't mean it will all the time. And remember this, because when I answer the cold starts question, this will come back. So in fact, containers live much longer than you would expect if they're not handling requests. And that's because as soon as a container is handling 0 requests, the CPU is throttled to nearly 0. So this means that your application will run at a really slow pace, right? So say hi to that throttled turtle that Natalie mentioned in the introduction. So if your container is not handling requests, it will be throttled, and you're not paying for it, right? And that's one of the reasons that you will see a lot less cold starts on Cloud Run, because the idle containers are there. And you can even tell Google to keep a few idling containers there. You will pay like 1/10 of the price, but you won't have cold starts because they can switch instantly from throttled to not throttled and start serving requests, right? So cold starts on Cloud Run can be an issue, but a lot less than you would expect from the function as a service platforms. Because Cloud Run shuts down, and this is like if you're zoning out a bit because you like the droning noise of my voice, pay attention now, because Cloud Run shuts down and throttles idle containers. And this means you should complete all work before you return the HTTP request to the user, right? So if you are running any tasks that you want to complete in the background after returning an HTTP request, they might not complete, because it might be the last request that runs on that container, and it will be throttled. So it means that will be very slow, and then it might be stopped, and the background task might stop with it. And this is confusing sometimes. I'm not saying that you cannot use background threads, right? You might be using some non-blocking IO thing and handle all the work in a background thread. That's fine. Just make sure to finish all processing before you return a request to the user. And that request, the solution is, if you do want to do backgrounds, because sometimes you just want to return a request to the user and then do some work, right? The solution is to, turn your background tasks into HTTP requests. And there are 2 products on Google Cloud that help with this, Cloud Tasks and Cloud Scheduler. Cloud Tasks is like, hey, Cloud Tasks, can you execute this HTTP request for me and wait until it finishes, and tell me if it succeeded or not. They're both well integrated with Cloud Run and Cloud IAM to make sure that only Cloud Tasks can actually call your service. There's another consequence to this concept of disposable containers that can disappear at any time, because you don't have any control on when they start and stop. And on a traditional server, you would store data directly on the server instance, and then it will be there, right? And on Cloud Run, that's not possible. That's not compatible with the runtime. So while the disposable containers on Cloud Run have a small disk you can write to, the entire file system is in memory and it disappears with the container. Well, this means you'll need to store persistent data in a downstream system, and probably if you're building a scalable system, you're doing that anyway. So you can store binary data in cloud storage, which is the blob storage on Google Cloud. Session data goes to that Redis thing. There's a managed version on Google Cloud that's called Memory Store, and your application data goes into that familiar relational database. So you don't have to use Firestore to build a serverless application. But, well, keep in mind the scaling boundaries, because your relational database might not handle it. But you can just use Cloud SQL, the managed database on the Google Cloud, PostgreSQL, MySQL, MS SQL, and use that as a backend to your serverless application. So the key thing to remember here is that while you can write data to disk, you should be prepared to lose it. So if you want to keep it, save it downstream. Yeah, applications on Cloud Run are portable. So portability is a valid concern for most application developers, and here's a couple of reasons why. So maybe your application needs to run in a geographical region where Google Cloud has no physical presence, and maybe you're also required to run it there and store your data there. Maybe as a developer, you want to avoid vendor tie-in and reduce the switching costs when you move to a different vendor. So applications on Cloud Run are portable in two ways. So first, there's containers. Well, you already learned from the beginning of this session that containers can run anywhere, which makes your application inherently portable if you don't start depending on something that's proprietary and only on Google Cloud, like Firestore. And the platform Cloud Run itself is API compatible with Knative. And that's an open source project that you can install on top of Kubernetes, the container as a service thing. And it's an entirely different implementation of the same API, the runtime API. So this means that you can take your Cloud Run application to Kubernetes, and you get the same runtime behavior and the same API to deploy your application, but it runs on your own infrastructure, maybe even in your own data center or on your cluster of Raspberry Pis in your closet. All right, so to summarize, before we head on to the demo, you learned about container images, how they are a package of your application and everything it needs. Your application can be written in any language, using any library and any binary. Cloud Run takes a container image and turns it into an HTTPS endpoint. It expects your application to listen to port 8080 or another one and respond to HTTP requests. And to deploy your container image, you create a service resource. And this is what the thing you will interact with primarily to deploy a new version, roll back to a previous version, and change configuration settings like environment variables, scaling boundaries. And the pricing model, finally, is unique because you are charged only for container time while handling requests. And a consequence of this model is that you can't rely on background tasks because they might not complete. Like, do your work before you return the HTTP request. Before I head into the demo, which is I will demo using the terminal, but there's two primary ways to interact with Google Cloud. One is the web console, and the other is the G Cloud terminal command line interface, which is great. But the web interface is a great way to get started, right? Because most products feature polished getting started wizards that guide you through creating your first resources. I mean, generally the usage of the Google Cloud Web Console is a nice experience. It's almost like they invest time in developing a great UI. It's a great getting started experience. So, but the G Cloud command line interface offers a good user experience for those who like the command line, like I do. So you can write scripts, you get helpful suggestions if you mistype a command. So off to the demo. Quickly checking if there's more questions. The cold starts. I think I covered that. If it's still unclear, pop something in the comments. Again, I will get to it. Anyway, so hi, here's my demo application. It's a small Go application. So there is this, I'll zoom in this thing a bit. There's one Go file, an index.html template, and there's a Docker file that describes how I need to turn this Go code into a container image. Let's run it locally. Go run main.go. And where is my... Yes, I do want to allow that. And then if I refresh, there's this. Give me 1 sec. I made a script of the demo and I lost the screen, finding it, found it. Yes, yeah. So run. Okay, go run main go. I did that. I'm on track. Excellent. Okay. So what's here? This is my little app, and it tells you metadata. It tries to get it from the environment. So first, it tries to it interrogates the place where it runs for the total memory, and that turns out to be 32 gigs. And my laptop has been running for 1 day and 7 hours. And there's a lot of environment variables, the request headers of the incoming requests. This will become more interesting when I deploy it to Cloud Run, because I will also interrogate the Google Cloud surrounding. So you will get like, what region am I deployed in? What's my instance name? What's my service account? That's there. So there's the red button. If I click it, it sends a REST API call, and that stops the instance. So let's do that. And then it refreshes the page. So REST request is sent from the page. It stops the instance, and after a short wait, it refreshes the page, and boom, the process is gone. And it also shows that in the terminal. Okay, with that said, let's go get this thing to Google Cloud. Yes, so remember, first I have to create a container image that goes through artifact registry as an intermediary storage, so, in a Docker repository. So I need to create that Docker repository first on Google Cloud. I'm using gcloud now, gcloud. I'll show you like I do it when I first try to work with something on Google Cloud. So I will do gcloud artifacts. Okay, well, this it expects more of me. And then will tell me, okay, you can manage artifact registry container images. No, that's not what I want to do. I want to do repositories. Yes, I want to manage a repository. In fact, I want to create one. Repositories. There we go. Boom. It lets me create one. gcloud artifacts repositories create. This needs a location. Good. Okay. This means I can choose a Google Cloud region. For this demo, I will just use US, and it probably needs a name. Let's call this Cloud Run demo, and I need to add a repository format, right? Because there's Docker repository, Java, and npm repositories. I want to have a Docker repositories. There we go. Repository. Always when people watch me type, I get very slow. Repository format, Docker. It will create it. Yes, it works. Good. All right. So I need to update my gcloud. I'm going to do that later, not now, because that's like trying to insult the demo gods. Now I need to build that image I have locally here, right? So I have a Docker file. So I will build that thing locally and tag it with the appropriate image URL, and then upload it to the repository that I just created. But let me create a few environment variables first, because I will need the name of the project. So project is now filled. If I echo it, echo project, with the name of the project, the Google Cloud project. On Google Cloud, you have a project, and you use it to organize all your resources. So you will generally put everything that belongs together in one project, and then you can easily connect the pieces. But connecting things from different projects is much harder. So it's a way to organize your system. Yeah, so and this is a subshell, just in case you're not a bash magician. So the output of this command goes into this environment variable, because the dollar thingy here. And then I'm creating another variable for the image URL, and that's this. So image is us docker package.dev, that's the artifact repository URL, then that project, remember how the project organizes everything, well, this is where it happens. Then the repository name, I just created it, and this is finally the name of my image. Now, and I can now build my app locally, Docker build with a tag image, and then using the file Docker file. This is optional, I know it, but I want to spell it out and make it visible. It's building the app, so it copies all the Go files from the build context, and then it does a Go build, and then I use a distroless container for running. It's great, but that's a different session. Okay, now I need to push it to that the Docker repository on artifact registry that I just created. But first, I will need to tell Docker how to authenticate with Google Cloud. And I can do that with, I can have gcloud tell Docker how to authenticate. So that's what I'm going to do now. Gcloud auth, configure Docker. So please gcloud, configure Docker for me, Docker. To talk with the with the artifact registry thing on the location that I created my repository in. And I already did that. So you need to do this only once, right? So you don't have to do this every time, only once. Yeah, well, and then I can push my image, Docker push image. It pushed. Okay, so it's in the cloud. My container image is in the cloud. I can deploy my service. I will do that using gcloud run deploy image, and then my image URL, and then a name, hello world, and then I want to set it to allow unauthenticated requests. Authenticated. Wow. Authenticate. Copy and paste. People watching me type, that's such an. There we go. Allow unauthenticated. And it's creating my service now. So in seconds, I am able to show you how it looks like. I get a service URL, and this is that unique HTTPS endpoint, which is unique for every service in my project, and unique to, because of this thing, that's a hash of my Google Cloud project name. And yeah, so there, and you can use custom domains. So there it is, and there's more metadata. Is this readable? Yeah, I suppose it is. I will zoom in a bit. So the total memory of my instance is 265, no, 256 megs, and the uptime when it served and when it run this request was 0 seconds. Well, that makes sense because it was the first request, and Cloud Run starts containers on demand. I have one vCPU. It's running in the US Central 1 region. This is a service account, so every Cloud Run service has its own identity, and you can use it to give it permissions to access other Google Cloud services. And I have an instance ID. I made it a color because I'm now going to stop this container, and then the page will refresh, and a new container serves the request. So that's good, right? This auto healing is going on there, and I have some environment variables. This one tells me the revision because this was the first revision, and the service name. And then the headers for my requests. You'll see a few tracing tokens there. Well, it's useful to look into that. But now I first want to show you that if I stop the container instance, a new one pops up and it serves the request. And then if I refresh the page, I will see that the uptime increases, right? So I will keep this humming for a while. So this particular instance, it served 2 requests, right? So if you go back to the pricing model of Cloud Run, that means I've probably paid for, it has a granularity of 100 milliseconds. So I've probably paid for 200 milliseconds of CPU time. But if I refresh the page now again, my container is running for 32 seconds already, right? So I've sent 3 requests. I've paid for 300 milliseconds of container time and the time it took to start up. But the uptime of my container, the full time, is already 32 seconds. So if you're asking about cold starts, this is a part of the answer. Nice, Wietse. Thank you. Yes. So what else did I? Yeah. Let me show the how it works when you edit code and deploy, because I was raving about the developer lifecycle. So let's change inspect here to hello build meetup folks, build tech folks. So what I need to do now is do a Docker build again. So I'm doing this locally, but you can do it in your CI, obviously. Building the container, then pushing it, Docker push, same image. It's probably pushing only the changes, but that's just one code binary, so that's the full thing anyway. And then I do a deploy again. Same thing. I could have also, if you look at how, like, I use an imperative deploy command, but I could have also updated the service resource. And it creates my second revision with my new version of the container image. And if I refresh the page, hello, build stack talks. So that works. That's actually a pretty fast turnaround. And then the revision name is now the second revision. All right. So I promised that I would show you a Dockerfile-less or source-based workflow. And here it goes. I will change the title again. I will make it say, look, no Dockerfile. Well, that's a weird word. Let's save it as look, no Dockerfile. Yes, and then I will remove the Dockerfile, rm Dockerfile. It's gone. It's really gone. There's no Dockerfile. And then I will do gcloud beta, because this thing is, well, it's in beta. It will probably become GA soon. And I will do run deploy hello world, same service. And then I will just say source. And then this directory. So the dot here is the current directory. And this will take a while, because what happens now is that we'll take my source code in my directory locally, upload it to Google Cloud, and then figure out what to do to build it. So in this case, it will look at the directory, see a go.mod file, and figure out, well, this is going to be a Go application. So I know what to do. I will build this for you. And what I really like about this is that Google Cloud open sourced the technology behind that. So you can reproduce everything that happens now, that's happening now in Google Cloud. You can reproduce it locally, because you can use a command line tool that's called pack, and you can tell it to use the Google Cloud build packs, and then you can do the same thing, right? And you can inspect everything that happens and create your own version if you like. So it supports, out of the box, it supports Go, Python, Java, yes, Java as well. So that's great, right? But it takes a while, because, well, the whole process is longer. And on Google Cloud, it didn't have the convenient already cached thing, because I ran it before the demo. But it works, and it's hands-off, right? I don't have to worry about creating that perfect Docker file and making sure that it didn't run as root, and that there are no system libraries with security vulnerabilities in there. Well, let's refresh. Look, no Docker file. Hey, it works. That's good. I'm always happy when that happens. I guess that concludes my my talk. Yeah, make sure to connect with me. Buy my book. If you follow that link, you will find me again. And I see Natalie popping up again. Hi. I think you're on mute still. Yes. Hi, Bart.
Hello, Wietse. Hello, Bart.
Hi.
Glad you were able to join us again. We are running a bit late now, so we do the Q&A with the three of us at the moment. So there were a few questions. Another question to Wietse. Answered most of them, but do you also have some advice on running a framework that has a life cycle like Spring on Cloud Run?
Yeah, so I'm having to guess now what the question is really about, because it has a longer startup time. Well, the thing with Cloud Run is that it starts sending requests to your running container as soon as it accepts TCP connection. So you'll have to make sure that that's ready to handle that HTTP request on the moment you open a TCP port. What's your view on when one should go for a container-based solution and when to go for a serverless functions-based? Well, so Cloud Run does both. And it depends on whether you want to be responsible for turning your source code into a container or that you want your vendor to be responsible for that. I think that's the main thing. So some people like to have full control about that and want to create the perfect container. And some people like to not have the responsibility and have your vendor take care of it.